It's dusk. The sun has just dropped below the horizon. The air is warm and absolutely still. You're lying on the ground, trying to sleep after a long day of walking and gathering, and then you hear it. That high-pitched whine, right next to your ear, the most universally hated sound in human history. You slap at it instinctively, miss. It comes back. Closer. This time you cover your head with your hands. It finds the one small gap between your fingers. You wrap yourself in your animal skin blanket. Pull it tight around your face. Nothing works. The whine turns into a chorus. The chorus turns into a symphony. And you lie there, awake, exhausted, listening to the sound of thousands of tiny wings, knowing that every single one of those wings is attached to an insect that wants to pierce your skin and drink your blood, and that a single one of those bites could give you a disease that will kill you in a week. Now imagine you have no blanket, no window screen, no insect repellent, no mosquito net, no walls at all. You're sitting in the open air, 30,000 years ago, in a landscape swarming with mosquitoes, and the only thing standing between you and the deadliest predator in all of human history is your own brain and your own two hands. How do you survive? The popular answer to this question is simple and grim. You don't. Ancient humans just endured. They scratched their bites, got infected, died young. Malaria was a fact of life. There was nothing anyone could do about it. It's a bleak picture, and it's not entirely wrong. Mosquitoes have been killing humans for a very long time, and they've killed an almost incomprehensible number of us. The World Health Organization estimates that mosquito-borne diseases still kill over 700,000 people every year in the 21st century, with access to modern medicine. Before modern medicine, that number would have been vastly higher. The mosquito is the single deadliest predator that has ever hunted our species. But the picture of ancient humans as passive victims of mosquitoes is incomplete, deeply incomplete, because the archaeological and anthropological evidence reveals that our ancestors were not helpless against the mosquito onslaught. They fought back, actively and intelligently, and they developed a multi-layered defense system, so effective that some of its components are still in use today, validated by 21st century science as being equal to or better than our best synthetic alternatives. Let's start by understanding what our ancestors were up against, because the scale of the mosquito problem is almost impossible to overstate. This is not a modern pest that appeared with the invention of agriculture or cities. The mosquito has been biting humans for as long as there have been humans to bite. The oldest confirmed human case of malaria, identified through ancient DNA analysis of skeletal remains from Europe and the Middle East, dates to at least 50,000 years ago, and scientists believe the actual figure is much older. A landmark 2002 study by Dr. Richard Carter at the University of Edinburgh, published in Nature Reviews Microbiology, traced the evolutionary history of the Plasmodium falciparum parasite through genetic analysis, and concluded that it has been infecting the human lineage for somewhere between 50,000 and 100,000 years. Our species and this parasite co-evolved together, each one shaping the other's evolution. The mosquito has been a permanent feature of human existence outside of the Arctic for the entire history of our species. Now let's build the ancient mosquito defense system from the ground up. Layer 1 is the oldest and most universal mosquito control method ever invented. Every human society that had access to fire discovered that smoke repels mosquitoes, and this discovery was made independently countless times across the globe. The mechanism is both physical and chemical. Physically, smoke creates a barrier of particulate matter that mosquitoes struggle to fly through. The tiny particles interfere with the mosquito's ability to detect carbon dioxide and body heat. They're two primary methods of homing in on human prey. Chemically, smoke carries volatile compounds from whatever is being burnt, and some of these compounds are directly repellent or toxic to insects. A 2013 study from the London School of Hygiene and Tropical Medicine quantified what every pre-industrial human already knew. Smoke from traditional cooking fires reduced mosquito landing rates by up to 85% in controlled field tests. That's not a marginal improvement. That's a massive reduction in disease risk, achieved with nothing more than wood and fire. But here's where the story gets more interesting. Ancient humans quickly discovered that not all smoke was equally effective. Through generations of trial and error, they identified specific plants that produced smoke with superior mosquito-repelling properties. 2017 study led by Dr. Jenny Carlson at Uppsala University in Sweden systematically analyzed traditional mosquito smudging practices across Africa, Asia, and the Americas. The study found a pattern that should not exist if these practices were random, trial and error. Indigenous communities on different continents, with no contact with each other, independently identified the same small set of plants as producing the most effective mosquito-repelling smoke. Neem, in South Asia, Azadirachta indica, containing the powerful insecticidal compound azadirachtin. Eucalyptus in Australia, containing eucalyptol and other volatile terpenes. Citronella grass in Southeast Asia, containing citronellol and geraniol, two compounds now recognized by the EPA as effective mosquito repellents. Juniper in North America, marigold in Central America, pennyroyal in Europe. These plants share a common chemical characteristic. They produce volatile organic compounds that are specifically repellent or toxic to insects. The indigenous communities that identified these plants were not engaging in superstition or guessing. They were conducting an empirical research program that ran for thousands of years, with the participants' lives as the stakes and their health as the reward, and they identified the same solutions that modern entomologists have confirmed through laboratory analysis. Layer 2 of the ancient defense system goes a step beyond smoke. Prehistoric humans developed topical repellents made from crushed plant materials and extracted oils, applied directly to the skin. The evidence for this practice is extensive, drawn from both archaeological analysis and ethnographic observation of traditional societies. A comprehensive 2011 study published in Acta Amazonica by Dr. Afonso Paulet at Brazil's National Institute of Amazonian Research cataloged over 300 plant species traditionally used as mosquito repellents by indigenous communities across the Amazon River basin. The study subjected many of these traditional repellents to controlled laboratory testing, and the results were striking. A significant number of the traditional plant-based repellents demonstrated measurable, dose-dependent, repellent activity against several mosquito species, including Aedes aegypti, the primary vector for dengue and yellow fever. Some of them showed repellency rates comparable to N-niethyl metatoluamide, better known as DEET, which has been the gold standard of synthetic mosquito repellents since it was developed by the United States Army in 1946. Consider the neem tree as a specific case study. Azadirachta indica has been used as a mosquito repellent in South Asia for at least 4,000 years. The leaves are crushed and rubbed directly on the skin. The seeds are pressed to produce neem oil, which is then applied as a concentrated repellent. The leaves are burned to create repellent smoke. Neem oil contains a complex mixture of bioactive compounds, most notably azadirachtin, which works by disrupting the feeding behavior of mosquitoes and interfering with their ability to detect human hosts. In 2016, a randomized controlled trial published in the Journal of the American Mosquito Control Association directly compared the efficacy of neem oil against a standard synthetic repellent containing 20% DEET. The study used a standardized arm and cage method, where human volunteers inserted their repellent-treated arms into cages containing host-seeking female mosquitoes, and the time until the first bite was measured. The result: neem oil provided more than 90% protection against mosquito bites for up to 8 hours. That is not a folk remedy. That sort of works if you believe hard enough. That is a plant-based repellent that performs at the same level as the best synthetic chemistry we have, derived from a tree that grows wild across an entire continent and requires no industrial processing. Layer 3 of the ancient mosquito defense system is a piece of technology so simple that it barely registers as technology at all. The mosquito net? The principle could not be simpler. Place a physical barrier between your body and the mosquitoes, and they cannot bite you. But the implementation of this principle required a sophisticated understanding of materials, weaving techniques, and mosquito behavior. Archaeologists have found evidence of net-like textiles used for sleeping in ancient Egypt dating back more than 4,000 years. These nets were woven from fine linen thread, creating a mesh that was dense enough to block mosquitoes while still allowing air to flow through, a critical feature in the Egyptian climate. In ancient China, silk was the material of choice for mosquito nets. Silk fibers are naturally finer than linen or cotton, allowing for a tighter weave that could block even the smallest mosquito species. Chinese texts from the Tang Dynasty, around 700 CE, describe mosquito nets as essential household items, with specific instructions for their manufacture and care. In sub-Saharan Africa, where malaria was endemic and mosquitoes were a constant threat, communities wove nets from locally available plant fibers such as jute, hemp, and palm leaf. These nets were coarser than the silk nets of China or the linen nets of Egypt, but they still provided significant protection by reducing the amount of skin area accessible to mosquitoes during sleep. The key insight was the same across all three continents. The mosquitoes that transmit malaria are most active at night, and sleeping is when humans are most vulnerable. Protecting the sleeping space was the single most effective intervention possible. The genius of the mosquito net is that it requires no ongoing input once constructed. No fuel to gather, no plants to crush, no oil to apply. You build it once, hang it over your sleeping area, and it works every single night with zero additional effort. A major 2015 study, published in the journal Malaria Journal, a Cochrane collaboration, meta-analysis combining data from more than 20 clinical trials across Africa and Asia, found that consistent use of insecticide-treated mosquito nets reduced malaria transmission by up to 50% in endemic regions, a 50% reduction in the deadliest infectious disease in human history, achieved with a technology that an Egyptian pharaoh would have recognized perfectly. The materials have changed from linen and silk to polyester and polyethylene. The principle hasn't changed at all. Layer 4 goes beyond personal or household protection to the level of the entire settlement. Ancient humans managed their physical environment to reduce mosquito exposure before mosquitoes ever became a problem. This required a sophisticated understanding of mosquito ecology that could only be accumulated through many generations of careful observation. Communities preferentially settled at higher elevations whenever possible, and this choice was not coincidental. The University of Oxford's Malaria Atlas project has shown that malaria transmission drops by approximately 20% for every 100 meters of elevation gain in tropical regions due to the cooler temperatures that slow parasite development inside the mosquito and reduce mosquito survival rates. Ancient humans who lived at higher altitudes had lower exposure to mosquitoes, and they knew it. Communities positioned their camps and villages upwind of mosquito breeding sites, marshes, swamps, slow-moving rivers, because they observed that biting insects were less numerous on the windward side. They cleared dense vegetation around their settlements, eliminating the shaded, humid microhabitats where mosquitoes rest during the day, making their immediate environment less hospitable to the insects. They designed their shelters with specific orientations to take advantage of prevailing winds, creating airflow that made it harder for mosquitoes to fly and land. Dr. Steve Lindsay at Durham University has spent more than 25 years studying the relationship between human settlement patterns, housing design, and malaria transmission across Africa. His landmark 190-18 study, published in the Annals of Tropical Medicine and Parasitology, analyzed traditional housing in malaria, endemic regions of West Africa, and identified several consistent architectural features that appear to have been deliberately developed for mosquito control. Raised sleeping platforms that kept sleepers above the ground level zone, where mosquitoes are most active, because mosquito flight height is limited. Open eaves and vented roofs that allowed smoke from cooking fires to escape while creating continuous airflow, and the specific placement of cooking fires within shelters, positioned so that smoke would flow across sleeping areas before exiting through the roof, creating a mosquito barrier. These features appeared in different cultures with different architectural traditions, suggesting convergent evolution of design solutions to a common problem. Layer 5 is the most sophisticated component of the ancient mosquito control system, and it has the most surprising modern relevance. A flower, specifically the chrysanthemum. Certain species of chrysanthemum produce a group of chemical compounds called pyrethrums, which are among the most powerful natural insecticides ever discovered. When a mosquito makes contact with pyrethrum, the compounds bind to voltage-gated sodium channels in its nerve cells, causing these channels to remain open. The result is continuous nerve firing, uncontrolled muscle spasm, paralysis, and death, all within milliseconds. The insecticidal properties of chrysanthemum flowers appear to have been discovered independently in multiple regions of the ancient world. In Persia, dried chrysanthemum flowers were crushed into a powder and used as an insecticide for crop protection and household pest control as early as 400 years before the Common Era. The Persian physician and philosopher Avicenna, writing in the 11th century, described in his Canon of Medicine the use of powdered chrysanthemum flowers for treating lice and other external parasites. In China, chrysanthemum-based insecticides are documented in agricultural texts from the 1st century of the Common Era, with specific instructions for cultivation, harvest, timing, and processing methods. In East Africa, the pyrethrum daisy, Tanacetum cinerarifolium, was used traditionally for insect repellent, long before European colonizers recognized its commercial value. Today, pyrethrins are approved for use in organic farming and are widely considered one of the safest insecticides available. They are highly toxic to insects, but have very low toxicity to mammals. Because mammals process the compounds differently, they break down rapidly in sunlight and air, leaving no persistent residue in the environment. The ancient Persians discovered a natural insecticide that 21st century chemists, with all their technology and knowledge, have been unable to improve upon in terms of the ratio of insect toxicity to human safety. There's one more layer to this story that doesn't fit neatly into categories like smoke or nets or plants, and it may be the most important of all: the cultural transmission of mosquito knowledge. In traditional societies around the world, the management of mosquito protection was not casual, haphazard, or left to individual initiative. It was specialized knowledge held by specific individuals who served as the community's environmental health experts. These knowledge keepers could identify the correct plant species for repellent use across different seasons. They knew the proper preparation methods. They understood mosquito life cycles and breeding habitats. They could predict when mosquito populations would peak based on rainfall patterns, temperature, and lunar cycles. And they passed this knowledge down through generations using oral tradition, practical demonstration, and storytelling. A 2019 ethnographic study by Dr. Kelly Shu at the University of Hawaii documented how this transmission process works in indigenous communities in Thailand and Myanmar. The study found that children as young as 5 years old could correctly identify the specific plants used for mosquito repellent, describe their preparation, and use them effectively. By age 12, they could independently construct mosquito-protected sleeping shelters using traditional methods. The knowledge was never written down. It was transmitted through direct experience, observation, and the immersive learning process that anthropologists call situated learning. The community produced its own experts through years of practice and exposure. Now, here is where this ancient knowledge connects directly to your life in the 21st century. The World Health Organization reports that mosquito-borne diseases kill over 700,000 people per year. Every year, malaria alone kills over 600,000. The vast majority of them, children under 5 years old, in sub-Saharan Africa. And the situation is getting worse, not better. A 2016 study led by Dr. Janet Hemingway at the Liverpool School of Tropical Medicine, published in Nature, documented widespread and growing resistance to pyrethroid insecticides among mosquito populations in more than 60 countries. The synthetic chemical weapons we have relied on for decades are failing. As mosquitoes evolve, resistance faster than we can develop new compounds. Meanwhile, the ancient methods still work. Smoke still provides effective protection, validated by modern field studies. Physical barriers still reduce transmission, confirmed by every clinical trial ever conducted. Environmental management still lowers mosquito populations, as demonstrated by decades of public health research. Many traditional plant-based repellents still show efficacy in controlled laboratory trials. The World Health Organization now actively promotes what it calls integrated vector management, a framework that explicitly combines chemical and non-chemical approaches. It draws directly on the same multi-layered strategy that ancient humans developed tens of thousands of years ago, through observation and experience, without laboratories or grants or peer-reviewed journals. The next time a mosquito lands on your arm and you instinctively slap it, take a moment to consider the full context of what you are participating in. You are fighting in a biological war that has been going on for longer than any human conflict. The mosquitoes buzzing around you belong to a lineage that has been drinking vertebrate blood for over 100 million years. Since the age of dinosaurs, they have evolved to track you by the carbon dioxide in your exhaled breath from 50 meters away. They can sense your body heat from a distance of several meters. They are attracted to specific chemical compounds in your sweat. They have evolved resistance to our most potent synthetic insecticides. But you have something they don't. You have 100,000 years of accumulated knowledge from countless generations of humans who faced the exact same problem and developed working solutions. You have smoke and fire and the knowledge of which woods burn best. You have neem and citronella and the knowledge of how to prepare them. You have nets and screens and the knowledge of where to hang them. You have the accumulated wisdom of everyone who ever sat by a fire, crushed a leaf, or wove a screen. They survived. They passed their knowledge to your ancestors, and your ancestors passed it to you. The war is not over. It will never be over, but you are not fighting it alone. You never were.